Hey everyone, and welcome. Today, we're going to tackle a shape you see literally every single day, but you might not know about the hidden rules that make it work. Get ready to master the world of circles and learn the secrets that are going to help you ace your next math exam. So just think about it for a second. What do these things have in common? We see them everywhere, right? From the giant Ferris wheel at the fair to the pizza on your plate. What's that one perfect shape that ties them all together? You guessed it, they're all perfect circles. And trust me, getting a handle on their properties, that is your golden ticket to crushing a whole bunch of problems in your math class. So you ready? Let's dive in. All right, first things first. Before we can do anything cool, we've got to learn to speak the language of circles. And no, this is not just some boring vocabulary list. Think of this as getting your essential toolkit, the stuff you absolutely need to become a pro. Okay, so what even is a circle, really? Well, it's just a bunch of points, a collection of points on a flat surface that are all the exact same distance from one single point in the middle. That middle point, we call it the center. And that fixed distance, that's the radius. Seriously, remember those two words, center and radius. They're the absolute foundation for everything else. Now, what happens if you draw a straight line all the way across the circle, right through that center point? Bam! You've just drawn the diameter. And here's a super simple but really powerful rule to remember. The diameter is always just 2 times the radius. It's that simple. Oh, and it's also the longest possible straight line you can fit inside a circle. But you might be wondering, what if that line doesn't go through the center? Well, any line that connects 2 points on a circle is called a chord. So that means a diameter is just a special kind of chord, right? It's the longest one you can possibly make. See? It all starts to click together. Okay, last one for the basics. An arc. This one isn't a straight line at all. It's actually a piece of the circle's curvy edge. So if you just pick any 2 points on the circle, you've actually created 2 arcs at the same time. A little one, the minor arc, and the big long one, which we call the major arc. Okay, awesome. Now we know the lingo. It's time to learn the rules of the game. And I want you to think of these theorems as like secret cheat codes for math. They're going to help you unlock and solve even the most confusing circle problems. Pay close attention, because this next one is a huge deal. If you've got 3 points just floating in space, as long as they're not in a perfectly straight line, there is one and only one circle that can pass through all 3 of them. I know, it sounds a little abstract, but this idea is the foundation for so many constructions you'll see on your exams. So how do you actually find this magic circle? It's a pretty cool process. First, you connect the dots to make 2 chords. Then, for each of those chords, you draw something called a perpendicular bisector. That's just a fancy way of saying a line that cuts it in half at a perfect 90-degree angle. And here's the cool part. The spot where those 2 bisectors cross, that's the center of your circle. From there, the distance to any of your original 3 points is the radius. Boom. Okay, exam alert. Here's why you really need to know this. What do you get when you connect 3 points that aren't in a line? A triangle, right? So this rule means that every single triangle, no matter its shape or size, has one unique circle that can be drawn around it, touching all 3 corners. And we call this the circumcircle. So when your exam asks you to find the circumcircle of a triangle, all you're doing is using the exact steps we just walked through. Okay, so we've got 3 points down. Let's get crazy and add a 4th one. What happens if you have a 4-sided shape, a quadrilateral, where all 4 of its corners are sitting perfectly on the edge of a circle? Well, that's a special shape, and it's got a special name, a cyclic quadrilateral. And this shape has its own awesome, super powerful rule. It's a game changer. For any cyclic quadrilateral, the angles that are opposite each other will always, and I mean always, add up to exactly 180 degrees. This little fact is going to be your best friend when you're trying to solve those tricky problems where you have to find missing angles. So here's the key difference, the thing you need to look out for. If all 4 corners are touching the circle, it's cyclic, and that means you can use the 180-degree rule. But if even one of those corners isn't on the circle, then it's not cyclic, and that whole rule goes out the window. It's a really simple visual check that instantly tells you what you can and can't do. Let's put this rule to work with a quick example. So you've got a cyclic quadrilateral, and you know one angle is, say, 110 degrees. So what's the angle directly opposite it? Well, we know they have to add up to 180, so 110 plus what equals 180? You just do a quick subtraction, 180 minus 110, and you get 70 degrees. See? It really is that straightforward. All right, you've got the vocabulary, you've got the secret rules. Now it's time to actually put it all into practice. This is the part where you go from just knowing this stuff to actually mastering it. And don't sweat it, we're going to start with some warm-ups and build our way up. Okay, let's kick things off with the easy questions. These are basically just a quick check to make sure all those basic definitions stuck. You'll see some fill in the blanks, some true or false, nothing too crazy. I'd say pause right here and see how many you can get right off the bat. Feeling good? Ready to level up? All right, here are the medium questions. Now, these are going to ask you to actually apply those theorems we talked about. You might have to set up a little bit of algebra or use some logic to figure them out. This is where you really start using the rules like tools. Go ahead, pause here, and give these a solid try. And now, for anyone who's looking for a real brain buster, here are the difficult questions. These are the ones where you have to build a whole argument, write out a proof. You'll need to connect different ideas together. Like that first one, proving a cyclic parallelogram has to be a rectangle. You've got to use what you know about parallelograms and what you know about cyclic quads. Seriously, if you can get through these, you are in fantastic shape. Okay, let's do a super fast recap of the absolute essentials. Number 1, a circle is all about its center and radius. Number 2, 3 points that are in a line make exactly one circle, the circumcircle. And number 3, the big one, if a four-sided shape has all its corners on a circle, its opposite angles add up to 180. Those are the rules you need to win the game. And I'm going to leave you with this quote from a famous mathematician, Paul Halmos. Look, watching explainers like this is great, but the only way to truly learn math is to do math. So go back to those practice questions, pick up a pencil, try them, get some wrong. It's totally fine. That's how you learn. Just keep at it, and I promise you will get this. You've totally got this.